Atomic Structure, Session number 1, Introduction, Review of Bohr's Atomic Model, Derivation of Expression for Radius of Hydrogen Atom. Introduction to Atomic Structure, the quest for atomic structure. Atom structure described differently by various scientists. Rutherford contribution is the first to propose a model on atom. He introduced the concept of electrons revolving in circular orbits. Rutherford's model and its setbacks. Rutherford model's strengths and weaknesses we will study here. Concept. Electrons move in circular orbits around a nucleus. This is the concept of Rutherford's model. Major setback is the stability issue. That means electrons, that is charged particles, moving in continuously loses around the nucleus, continuously loses the energy by emitting radiation. This would cause orbits to shrink, leading to electron falling into the nucleus. This phenomena is not observed in actual process, making the model unacceptable in its original form. Evolution of atomic models, building on foundations. Niels Bohr is the next model. Continued with the circular orbits. Niels Bohr introduced the quantization of circular orbits and discrete circular orbits. And this is the improvisation of the Rutherford's model. Sommerfeld. So Sommerfeld further improved the model by introducing elliptical concept, that is elliptical orbits. Next, de Broglie. So de Broglie showed that electron possesses a dual character, that means a particle and wave character. Importance of early models. Progress through iteration. None of these models were complete failures. Each model provided a crucial input to the next model. This iterative process highlights the essence of research and development in science. Dalton's atomic theory. The earliest view of atom was given by the John Dalton in the year 1809. So he regarded the atom as a hard, dense and smallest indivisible particle of a matter. Later discoveries, subatomic particles like electrons, protons and neutrons were discovered later. These are known as fundamental particles. Review of Bohr's atomic model, addressing Rutherford's limitations. Bohr's theory in 1913, developed by Niels Bohr, a Danish physicist. This is aimed to overcome the difficulties in the Rutherford's model. He has successfully explained the atomic spectra of hydrogen. This is based on the quantum theory. He has been awarded a Nobel Prize in Physics in 1922. Bohr's postulate number 1, nucleus and orbits. The atomic structure according to Bohr, an atom consists of a positively charged nucleus. The entire mass of atom is concentrated in the nucleus. The electrons will be revolving around the nucleus in certain circular orbits. Bohr's postulate 2, stationary orbits and energy levels, that is quantized orbits. These specific orbits do not emit radiant energy, that is they are called as stationary orbits. The electron will going to stay in those orbits. Each orbit is associated with a definite energy, also known as mean energy levels. Energy of an orbit increases as its distance from the nucleus increases. As long as the electron remains in a particular energy level, it neither emits nor absorbs energy. Postulate number 3, energy transitions. Electron jumps from one energy level to the another energy level. This will constitute transitions. Energy is emitted or absorbed by an atom only when electron moves from one level to the another level. The energy change delta E is equal to the difference in energy between the two energy levels. That is delta E is equal to E2 minus E1. The energy of an electron cannot change continuously. It changes abruptly when an electron jumps. Bohr's postulate number 4, that is quantization of angular momentum. The quantization condition, that is the angular momentum of revolving electron, is quantized. Because the electron is revolving around the nucleus in the circular path, we call this as angular momentum. Angular momentum mvr is an integral multiple of h by 2 pi. So here mvr is equal to nh by 2 pi, where m is equal to mass of electron, v is equal to velocity of electron, r is equal to radius of orbit, n is principal quantum number, that is 1, 2, 3, 4, etc. h is Planck's constant. Calculation of radius of orbits. Introduction. Deriving the orbital radius. Consider an electron of charge e, mass m, tangential velocity is v, revolving around a nucleus. So there is charge Ze, where Z is atomic number, E is the charge on a proton, and orbit. So radius of the orbit will be r. Balancing act. So the forces in an atom will be like this. Electrostatic and centrifugal forces will be present. The electrostatic force of attraction between the nucleus and the electron act as centripetal force. This force is given by Coulomb's law. The force equation and permittivity. Coulomb's law equation is given by F is equal to 1 divided by 4 pi epsilon naught into Z into E divided by R square. Where permittivity factor is present, that is 4 pi epsilon naught is the permittivity factor of the medium. It is introduced in SI system. We have to note here, in the initial derivation, this factor is sometimes avoided and it will be introduced in the final equation. Balancing forces of stationary orbits. Equilibrium in the orbit. For an electron to remain stationary in an orbit, centripetal force and centrifugal force must be balanced. That is, centrifugal force is equal to centripetal force. That is equal to centrifugal force is mv square divided by r. Centripetal force is z square divided by r square. These two should be equal. Deriving V2, that is equation number 1. Velocity squared from force balance. For an electron to present stationary in an orbit, centripetal force and centrifugal force must be balanced. That is, mv square is equal to mv square divided by r is equal to z square divided by r square. That is, centrifugal force should be equal to centripetal force. So if you cross multiply this, then you get v square is equal to z square divided by mr. Let us call this as equation number 1. Deriving V2 from Bohr's postulate, that is equation number 2, V square. So according to Bohr's third postulate, MVR is equal to NH by 2 pi. That is, V is equal to NH divided by 2 pi MR. Then square on both sides, you get V square is equal to N square H square divided by 4 pi square M square R square. Call this as equation number 2. Equating V2 V square expression and solving for R. The radius formula from the equation 1 and 2, we get Z square divided by MR is equal to N square H square divided by 4 pi square M square R square. That is, Z square is equal to you do the cross multiplication, then you get Z square is equal to N square H square divided by 4 pi square MR. The radius of the orbit is given by R is equal to N square H square divided by 4 pi square mz square. This equation is obtained by cross multiplying the above equation. For hydrogen atom, Z is equal to 1. That is, atomic number is equal to 1. Therefore, R is equal to N square H square divided by 4 pi square mv square. We call this as equation number 3. Radius for hydrogen and Bohr's orbit. Specific case, that is hydrogen atom, we will consider. For a hydrogen atom, the atomic number Z is equal to 1. Substituting Z is equal to 1 in the radius formula, the previous equation, this is the one we derived in the previous one. In this, R is equal to N squared H squared divided by 4 pi square mv square. In this, you substitute the Z is equal to 1. You get this equation. This is the equation number 3. For the ground state of hydrogen atom, N is equal to 1. This radius is called as Bohr's orbit, that is A0. So A0 value is calculated by A0 is equal to H square divided by 4 pi square mu square. So in this case, N is equal to 1. In the previous equation, we call this n is equal to 1. When n is equal to 1, then this equation becomes a naught, that is Bohr's first orbit. Revision: key takeaways from session 1: evolution of atomic models, from Rutherford's initial idea to Bohr's quantized orbits and the concept of dual nature. Bohr's postulates: understanding the core principles governing the electronic behavior in atoms, and quantization: the fundamental concepts that energy and angular momentum are not continuous but exist in discrete packets. Derivation of radius: how the mathematical relationship for orbital radius is established based on physical laws and Bohr's postulate. Importance of hydrogen atom: its simplicity makes it crucial for understanding atomic structure.